Hi everybody, welcome to the video. So this video will give you a brief introduction to ANSYS, so it should hopefully get you started and be able to run some basic static structural simulations. So you'll see on the screen that I've got a basic model produced in Creo, so it's just a simple plate with a hole in the middle of it. And what I'm going to do is run a simple structural analysis of this component. Now, the first thing that we need to do is take our 3D model and convert it into a neutral step file. Okay, so we can do that very simply. Just go File, Save As, save a copy, and then if you go into the drop down here, we're just looking for step and save it as a step file. So I've already got it saved as a step file, but I'll just overwrite it and we click OK. So once you've got your step file, we're then ready to take our part or assembly into ANSYS. Okay, so I'm just going to close down Creo, and then we're going to load up ANSYS. So what we're looking for in the start menu is something called ANSYS 19.1, or whichever the current version that you have installed on the machine. So if you click on that, you'll see loads of different programs, but what we're looking for is ANSYS Workbench. So if you click on this one here, the program will then load. Okay, so I've now got ANSYS Workbench loaded up, and what you're going to see is a list of analysis systems down here, and these are all the different kinds of analysis that we can run using ANSYS. So in this case, I'm just going to be running a simple static structural. So we can see here it's a static structural, and that's good for doing standard stress strain analysis of mechanical components. So in order to use the physics associated with this kind of analysis, all you need to do is basically left click, and you then drag this system onto the project schematic area. And now what you'll see is that we've got this static structural analysis, and our aim is to basically get a tick in all of these boxes. So you can give this a name if you want, and I'm just happy to leave it as it is. So the first thing you'll see is that it says engineering data. So this is basically where we need to specify the materials that are going to be used in our part or assembly. So what we need to do is click on, if we double click on this, so double left click, we'll open up a new window. And what you'll see is that as standard, the material that's defined is structural steel. So you can see it highlighted here in this top window. And in the bottom, it basically highlights all the material properties that are associated with structural steel. So we see things like the Young's modulus, Poisson's ratio, etc. Now, if you want to add any of your own materials, it's very straightforward. You can just click here to add a material, so you can type a name in. And then what you can do is bring various different properties down into this menu here. That's one way of doing it, but actually there is a built-in library of materials, so quite often you can find a material that you want from within ANSYS. So if you see up here, we've got these two tabs, and one of them says engineering data sources. So if I click on this tab, you'll see that now it says engineering data sources, and these are lots of different databases of materials that are actually inbuilt into ANSYS. So if I click on one of these, so let's go on this one here, what's then going to happen is we get a list of all the different materials within that database. So you can scroll down here, and you'll see we've got loads of different aluminiums. So we've got magnesium, nickel, there's plastics, we've got titanium, we've got all sorts of different materials in here. So if you want to add any of these materials to your analysis, it's really quite straightforward. So let's just find something for an example. Let's say we want aluminium wrought aluminium. So we can just click the little add button here. Now that's added it to our list of available materials. So if we untick this, and you'll see now that we've got structural steel and aluminium. So they're the two materials that we would then be able to select when we're running our analysis. You can have as many materials as you want in here, so it's just a case of having the materials that are there for your design. So I'm happy with the materials that I've selected now, so I'm just going to press X on this little tab up here to go back to the project. Okay, so we set our materials, we're happy with that. Now we need to start importing geometry. So to do that, we've got our step file that we generated earlier. So we just click on geometry here, and then if you right click, you can see that we've got this import geometry. So all we need to do is now find that file. So if we click on browse, we're looking for the step file here. So we click on that, click open. And what we now need to do is just check that that import is going to be successful. So to do that, we basically right click and go edit geometry in design modeler. So what you're going to see here is a new window, and this basically allows us to look at our models, and if you wanted to, you can even make modifications to your models from within the ANSYS environment. What you can see here is that you can see I've got an import, and it's got this little lightning bolt symbol next to it. So that just means that we need to generate it. So if I click on this and then click generate at the top here, you can see that we've now got our data imported into ANSYS. And you'll see that I've got one part and it's called test here. So it's successfully imported, so we've now got some geometry in there. So we can actually exit this window. And you'll see now I've got a little green tick next to geometry. It's saying that I've got geometry imported into the analysis. Now what we need to do is look at running, actually meshing our component and then setting the boundary conditions. And this is all done from the model tab. So if we click on this and then right click and go edit, this is now going to load up the main working environment that we're going to be able to mesh the component, apply boundary conditions, and also do some post-processing and get our results out. Okay, so we can see we've got our geometry in here. So when we're navigating this window, it's just like any other CAD package. So you can hold down the middle mouse button to rotate your object. You can zoom in and out using the scroll wheel. If you'd like to move the component, you can press Control, hold down the middle mouse button, and move it around. If you want to see it in a certain plane, you'll see we've got these little icons down here. So if I want to see it in the Y, I can just click on there. I want to see X, just click there. You'll see that it squares up the view for us. So the first thing that we're going to do is make sure that we've got the material set correctly. So if you click on, you'll see in this basically outline, project outline, it says model and we've got geometry. So you can click this little plus icon here and it says test, and then you'll see a table of contents down here, and this basically tells us information about our model. And here we've got material, so it says assignment, and currently it's structural steel. So if I want to change that, all I need to do is click on this field. You'll see that I get a little arrow next to it here. And then you'll see that I've got the material that I previously selected available for me. So I can just click on this aluminium. I've now changed the material definition for our shape. So that's fine. Now, what we want to do is mesh our shape. So you can see we've got a little mesh here, and again we've got this little lightning bolt symbol next to it. So that means that we need to do something. So if we click on this, what we can do is make it auto-generate a mesh for us. So if we basically, you'll see actually, when we click on mesh, you'll see that the toolbar changes along the top here. So these are our mesh controls, so we can do various things. We can specify a size, we can do refinement in certain areas, And so these are our tools in order to generate a good mesh for our component. But what you can do is if you basically click here and you right click, you can go generate mesh and it will auto generate a mesh for you. So let's do that. Okay, so we've got a mesh, you can see it's basically generated one there. And if we click on here, you can see that we can have a look at some of the properties of the mesh. So if we want to know what the size is, so we can go down here and we can see what some of the sizing information about it. So we've got the quality, various different statistics. So how many nodes, how many elements have all been given here. Okay. Now, using the standard mesh out of the box is not what we normally do. You would normally have to specify some kind of mesh size, and you may want to do that. That's very straightforward for us to do. So if we click on this drop down menu here, mesh control, sizing, and now you'll see that a new little box has come up here. So it says sizing here and it's got a little question mark. So it wants us to input some information, and the information that initially that it wants is the geometry. So if we're going to specify a size for the mesh, we need to tell it what geometry to the size is relevant for. So I want to set a mesh size for the whole component. So I'm going to come along to the top here, and this is our selection filter. So at the moment it's on face, so if I click on anything it basically highlights a single face. I'm going to go to body, and then you'll see that when I move over my mouse it highlights the whole body. So I'm going to left click on the body, and then I'm going to come along here, and then just click apply. So you can see now it's got body sizing and it's going to do the whole body there. So the default element size that we generated was 5.6 millimeters. So I'm going to change that. I'm going to go to 4 millimeters. And then what we need to do is go to mesh. You'll see that our mesh is now obsolete because we've told it we want to implement a change. And we can update that. So we just right click, click update. And this will then update the mesh, and you'll see that it's a little bit finer because I've specified a finer mesh for this component. Now, we've meshed it, so what we now need to do is add some boundary conditions. So to do that, what we need to do is change the menu, and to do that you can click on static structural. So once we click here, you'll see that the menus again change. So this time it's like support, loads, conditions, various different options for us. So what I want to do in this example, I want to fix this face here, and I want to apply a force to this face here. So that's fairly straightforward. You're going to click on supports, and I want a fully fixed support. So I'm going to click there, and you'll see again that we've got a fixed support in our menu, and it's asking me for some geometry. Now this time you can see that I want to select a face. It's automatically selected that tool for me. So if I click on this face here, click apply, you'll see that now that's going to be a fixed support, and that's everything we need to do for a fixed support. Now what we need to do is apply a force to this face. So if I go on loads, I can click force, and again I need to tell it what face I would like that to do. So we've got the face selection enabled, we click on this face here and we click apply. So now we're going to apply a force to this face. Now it's important that we know the direction in which this force is going to apply. So what I want to do, so in this definition tab, at the moment it's saying defined by a vector. That's not actually very useful to me at the moment, so I would like to do it in components. And so now you can see that I can specify the force in X, Y and Z. And X, Y and Z corresponds to this coordinate system in the corner here. So I want to pull it in this direction, so that means that it's in the X direction. So in the X component, I'm going to put a force. So I'm going to say 10,000 newtons. Okay, so we've got a little arrow showing us the direction, and it's got a force here. So if I click back on here, static structural, you see that I've got a fixed support here, and a force being applied there. So we've actually done everything that's required to solve this. So what we're going to do is we're going to click on solution, we're going to right click, and we're going to go solve. So now obviously it's going to go through the process of solving mathematical model. And you can see that it's actually solved it. But at the moment, we haven't actually done any post-processing to the results. So it's just got the results from the stiffness matrix stored in its memory. So we need to tell the software what we want to know. So you can see here when I click on solution, the menu again changes along the top here. And so we can get various different parameters out from this. So we can work out deformation, strain, stress, energy, damage, blah, blah, blah. But for this, what I really want to know is the strain, the stress and the deformation. So I'm going to go up here and I want to know the von Mises stress. And then also I'm going to add a deformation, so I'm going to have the total deformation. So you see that I've got little lightning bolts next to these. So to basically post-process the results, all I need to do now is click on this, right click and go evaluate all results. So that means it will take the data from the solution and map them to the required results. Okay, so that's really quick. And you'll see here that so we've got little ticks, so now we can start looking at our data. So if we click on equivalent stress, you can see now we've got our stress map. Let's square up the view. Okay, so we've got our stress. So stress concentration is at the tip of the circle. So this is actually pretty much what we'd expect. So I'm fairly confident that these results are good. I've also done a quick hand calculation, so using the parameters for this circle and this plate, the classical theory would tell me that the stress should be about 86.4. I'm getting about 89.5. That's very reasonable. You know, finite element is an approximation, so I'm fairly confident that these results are accurate. So when we're in this view, we can change the view a little bit, so we can see an animation of how the force is affecting the component. So if we come down to this tab and click play, we'll see that it expands. Okay, obviously everything's kind of exaggerated in the model. We can do this for deformation as well, so we can see how far the part's going to move. Okay, so it's all as we'd expect it to look. If we go back to equivalent stress, you can actually have a look at where the maximum stress is. Okay, so we've got a little tab up here, so that will display maximum point, minimum point. You can probe, so you can have a look and see how the stress changes over the component. Okay, you can click on different points and it will then show you a probe there. Go and take that. Okay, so we can get rid of that as well. Okay, you can also change the way that it looks, so if you don't want to have the wireframe, you can remove that as well. Show the undeformed model, so see how it looked before. Okay, so there are various different options in which we have. So you can, it's up to you how you'd like to display your results. So you can see ISO lines. Various different options. Now, if you get to the stage and you decide that you want to change some of the components, that's really change your mesh, change your material, we can just go back at any point. So if we go to mesh here, let's say that I'm not happy with this mesh, I want to increase the density around the circle. Let's have a look at that. So if we go mesh control, we can go sizing. And this time, I'm going to change it along the edges around this part. So I'm going to change the selection tool to edge. And then I'm going to select all the edges around this circle. So if I left click this edge, press Control, click the other edge. can then rotate the screen around, press Control again, and select these 4 edges, and click Apply here. And then let's change the default size. So let's change this to 1mm. Okay, so along the edges, we're going to refine our mesh. So we need to update our mesh. Obviously, it's obsolete now. So we're going to update that. Okay, so we've now got a fine mesh around the hole. And again, if we want to solve this, we can just right click down here and click Solve. So now that we've got these post processors in there, it will automatically generate our results. So here, okay, so you can see that the stress has actually come down a little bit, so it's actually a bit closer to what the theory says to that the stress around here should be. Okay, with a little bit of refinement. Okay, again, deformation. Okay. So that's everything for this tutorial.